Hi, welcome back to Harmony Search Algorithm Part 2, which is a practical part uh, of this video. We're going to show you a simple example on how we are going to implement Harmony Search step by step on an optimization problem. Now, these are the shortcuts of some variables or parameters of harmony search. HS is harmony search, HM harmony memory, which stores the best solution vectors. This is harmony memory size, number of solutions in the stored in the population of harmony search. Harmony memory considering rate, that is the probability of choosing a value from harmony memory, and par pitch adjusting rate. This is probability of slightly modifying a selected value. Bandwidth, this is amount range of pitch adjustment. Maximum iteration, this is the threshold stop criteria of the loop of the algorithm. Random value, this is the current solution or decision variable xi. You could have xi, x1, x2, x3. And here is the fitness function. Now we could have lower bound and upper bound for xi or x sub I, which is the dimension of the each solution. Now, this is the algorithm before we get into the practical example. Here we have objective function. It has two dimensions, x sub I, x1 and x2. Set bounds -5 and 5. This is the dimension, goes plus and minus 5. Set parameters, tree population, HMS, the size of the agents of harmony search, and considering rate for harmony memory is 0.8, pitch adjusting rate 0.5, and bandwidth is 0.1 for the local search. Initialize harmony memory. So this is how we initialize it. And this using upper bound and lower bound and random, we select and we evaluate each one, each solution. Then that's N4. And then we come to initialize X1 and X2, new axis. And we go with J to 2 because we have the dimension. And we generate R, a random value. We toss a random value between 0 and 1. If that random less than harmony search memory considering rate, then that value, a value from the column of harmony memory will be selected. That value will be assigned as a value. And then next we have to do R2, toss another value between 0 and 1. And if it is less than the pitch adjusting rate, then the new solution will be obtained by using this equation, which is current solution plus random between 0 and 1 multiplied by bandwidth. If and else, if you enter this if, then that's the else. But because we enter this if, so we don't need to do this else. So we end of if the next one, we go with the for loop. Next time we will try to get J2 because it was J1 and then J2. And N4, we evaluate the solution, and then we will get the worst solution. We replace it with the minimum that obtained in the xi fitness function, and we replace the worst solution in the harmony, and that end of N4, and then return the best solution. So here is the individual decision variable. Here is the full harmony vector. Here is the population solution, and that's considering rate for the harmony memory. This is adjusting rate for pitch, which is local tuning, and bandwidth, it is step size for exploitation, as we say, local search earlier. And then that's the worst solution in the harmony memory in the population, which would be replaced if new solutions are better. So here is the example, x1 and x2. That's the fitness function x1 square summed up with x2 square. And the dimension for x1 is in between -5 and 5, -5 and +5. And you have J1, 2. Parameters, we have three solutions in the harmony search size, and we have considering rate 0.8, remember all these, and parameter adjusting rate 0.5, and bandwidth is 0.1 for local search. So this is the random solution that we get. Harmony memory initial values 1, 3, 10, -2, 2, 3, 8, 4, -1, 17. So we can see that this is the best that we have, the best solution, the minimum 8 fitness. Now, in iteration 1, we tried to construct X new one. We say that was initialization, that's done with it. And we come to here, which is line 14. We go through, we construct x1 and x2, and we get the value. So we just toss a number, R, in line 14. And imagine between 0 and 1, we receive 0.4. Here, we receive 0.4, that number. And sorry, that number 0.4. So if that number is less than harmony search considering rate, which is 0.8, yes. Then we go to line 16. Line 16, we select a column J from harmony, and column J, it is, this one is selected, the first column. If we just go back to see the column J, that column is selected, this column 1, -2, 4, that one is selected according to the code, according to the line number of the code, which is this one, 16. So it's selected. Now, x1 new is 1. The first will be taken. And then we come to generate R2, which is 18. We toss another R between 0 and 1, and we receive 0.30. Now, 0.30 smaller than pitch adjusting rate. We say that the pitch adjusting rate is 0.5. Yes, it is great. Pitch adjusting rate is greater than 0.3. Then we go to, directly we go to line 20. In line 20, we will have update of getting a new solution by the new solution, which is one you have, okay, plus random number between 0 and 1, which we got at 0.5, and bandwidth is 0.1. So bandwidth 0.1 multiplied by random number between -1 and 1, which is 0.5, we tossed it, and plus the new solution that we receive, one term of the solution, which was 1 here, that solution, which is that, I mean, that is the cell of the column 1 is taken. Now we get x1 new is 1.05. Now we will try to construct x2 new. X2 new, we go to line 14. Why? Because this is here is finished. This here is finished. Sorry, this is here is finished. So end if, and then we go back to the for loop. We go back to the for loop here. So we go to the line 14, which is here, generate R, generate R. R is now 0.9. They generate R between 0 and 1. We got 0.9, and we check it with harmony memory considering rate, which is 0.8, 0.8, 0.8 greater than 0.9. No, so it's not satisfied here. This is not satisfied. So this if cannot be done, we come to where? We come to we come to line 15. Okay, line 15. Uh, line 15. We checked it. 0.8 greater than 0.9. No, we jump all the way to 23. Else, because uh, this one not satisfied. Point 8 not greater than 0.9. They are, so all the way jump. So we come to here, we come to here, we come to the else. In the else, it means x new equals the lower bound and random between 0 and 1, upper bound minus lower bound. Lower bound is minus 5 we have, lower bound of the dimension. So, and upper bound is 5. So minus 5 plus 5 minus 5 plus 5. So it will be minus 5 minus 5. It will be 10 multiplied by 0.6, which is the random between 0 and 1, then then 0.6 multiplied by 10, it is 6 minus 5, 1. So that's the result. Now, how we get minus 5? I take you back to the dimension that we have. That's minus 5 is lower bound, and upper bound is 5. So that's the equation we have talked about, which is here, which is here. That's the equation, because this if wasn't satisfied, this one wasn't satisfied. HMCR not greater than R1, not satisfied. We come back here. So X new 2 is found 1, 1, and then we have now two values. We have 1.05, which we found it here, and the next value 1. Plug them into fitness function, which is x1 square plus x1 square plus x2 square, and we get this result, the fitness 2.1025. This is far more less than fitness 17. So y is 17, x3 is 17. It is the x3 earlier in the initial iteration was the worst solution that we have. Let's check it. The worst solution that we have, it's x3. Now we improved new x's. So this one will be replaced. Now, that one is replaced now. Okay, that one is replaced. Now, we go for iteration 2. In iteration 2, likewise, we start with the, because we are in the for loop, and we will construct x1 and x2 new, and then we go through the for j equals 2. Now generate R, we will get R. This time R 0.25, 0.8 greater than 0.25, then go inside, select 1. So we select column 1. Column 1 is this one. Sorry, column 1 is this one, by the way. That's the column 1 is selected. Okay, so column 1 is selected, 1 minus 2, 105. So the new solution is selected 105. That's the new solution. Now we throw R2, and because that's the step we did it. Now we throw another coin, another random number. We toss another random number, which is R2 in between 0 and 1, which is here. So that is 0.75. And adjusting uh, uh, pitch adjusting rate 0.5. 0.5 is not greater than 0.7. So here, 0.5, this F is not greater. So we can implement this line because PA or pitch adjusting rate is not greater than R2. It is less. Then we can do that. We are in the line 19, and if is finished, and we can do the else because it was started with this F. We did the F, so we can't do the else. We go back to the for loop. We go back to the for loop in the line 14. In the line 14, we throw another R. That is 0.15 here. That's 0.15 here. Now 0.8 is greater than 0.15 that we received new. So we select column 2. And column 2, we will select X2 is 1. X2 is 1. And line 18, we throw R2, which is here. And luckily 0.5, the pitch adjusting rate is greater than 0.2. Then we will implement this equation right now. In that case, we will get random between -1 and 1, which is minus 0.8, and bandwidth is 0.1 multiplied by minus 0.8 plus the new solution, which is 1. That 1 is plugged into here. So now new solution is 0.92. Now, this is the new solution 1.05 and 0.92. Plug them, and then the fitness is 1.9482. This fitness is far less, and we will replace the X worst or the bad solution, the worst solution in the harmony with this solution. So here the bad solution was here. So we change it to that one, to the new one. So if so, that was the result that we have. So if we that's the bad solution. That's the worst solution that we have. This one will be cancelled. So we will replace it with this solution that we received. That's more or less about the harmonic search, and I hope you enjoyed it. And if you have any question, please check my website for further information, and stay tuned with more tutorials on algorithms. Thank you.